analyze titration data in Chemvue. I have here a set of acid-base titration data where I use the wireless drop counter to get fluid volume on the x-axis, and I use a pH sensor for pH data on the y-axis. To analyze and determine the pH and fluid volume at the equivalence point, I want to look at the most linear portion of data, which is right through here. And since I only want a region of the data for analysis, I'm going to use the selection tool and draw a box around the data that I care to analyze. What I want to do next is put a linear fit through this selection of data. And I can either click the red box to make the curve fits menu come up, or I can use the curve fits menu from the left. Either way, you want to use a linear fit. And that linear fit goes only on the selection of data. I need to see how symmetrical my selection is. If I imagine the midpoint of this linear portion, I should see equal shape of my graphed data on either side of that midpoint. So I'm going to have to zoom in or scale with my selection on to evaluate that. And I can see I did a pretty decent job of selecting, because when I compare the region between the graph data and the linear fit, I've got just about the same area under this curve versus linear fit as I do on the opposite point that past the intersection with my graph data. They're just about equal. So I'd say it's a pretty good selection. But if I wanted to change my selection and modify it, I could. I just have to grab any of the four handles, and that will adjust the linear fit and the point of intersection, and also you'll see the linear fit parameters change with my selection. But I'm pretty happy with my selection, so I'm going to now determine the pH and volume at the equivalence point. And again, that's where the fit line intersects the graphed data. That's right there in the center. That happens to be at pH 7, and a volume around 10.89. Well, it's hard to see that, so I can move my graph down a bit and manually scale to adjust the range, the data range, either on the x or the y-axis, so you can get a better estimate of the exact pH and volume at which the equivalence point occurs. And once you have the pH and volume, now you can use M1V1 equals M2V2 to determine the concentration of your unknown